When an expression inside parentheses is raised to a power, the inside expression is the base. So if we expand this, the base of m over n raised to the third power means we have m over n times m over n times m over n. Multiplying fractions together, we end up with m times m in the numerator, and in exponential form, that's m to the third. Multiplying in the denominator, n times n is n to the third power. If we look at where we started and where we ended up, we see that the numerator is raised to the power as well as the denominator is raised to the power. This leads to the quotient to a power rule, which states for any numbers a and b, b not being 0, and any whole number n, if you have the fraction or result of this division, which that's where the quotient term is coming from, raised to a power, it's equivalent to the numerator raised to that power over or divided by the denominator raised to the power. And because b is in the denominator, that's why we have a restriction on b not being equal to 0 to avoid an undefined expression. Let's use the quotient rule then to simplify some examples. We have a quotient here, a fraction raised to a power, and using the quotient rule, we'll take the numerator raised to that power over the denominator raised to that power. Because it is a reasonable number, integer to simplify, we can take this a step further. 2 to the third power means 2 times 2, which is 4 times 2. We can put an equivalent value of 8 for a simplified answer. In this next example, we can apply the quotient to a power rule as well. The numerator will be raised to the second power, and we'll treat the denominator as a quantity raised to that second power as well. In the numerator, since this is an integer raised to a power of 2, we can simplify 3 to the power of 2. 3 squared is equivalent to 3 times 3, or 9. And in the denominator, we have a power raised to a power. And using our power rule, we will multiply the exponents for a simplified 4 times 2, or exponent of 8, on the base of y. In this last example, similar as well, applying the quotient to a power rule, we'll take the numerator, treating it as a base initially, and raising it to the second power, and likewise the denominator, treating it as a base and raising it to a power. We now have a situation of a product raised to a power, so each of those factors will be raised to that exponent. The two factors here are 2, which will be raised to the second power, as well as x to the third power being raised to the second power. In the denominator, we have a power raised to a power, so we can simplify that with multiplication of those exponents. 4 times 2 is 8. Simplifying further in the denominator isn't necessary, but the numerator has a little bit of work. 2 to the second power, or squared, means 2 times 2, that base, times itself. We'll replace that with 4. And in the numerator, as we had in the denominator, we have a power raised to a power. Multiplying those exponents gives us a 6 over the y to the 8th for our simplified solution.